A high-pressure receiver, or HPR, is a critical component in many refrigeration systems, especially large industrial systems. The high-pressure receivers are typically arranged to receive liquid exiting the condenser. The receiver acts as a reservoir for the system, ensuring a steady supply of liquid refrigerant for distribution to the rest of the system. HPRs are particularly useful in systems with varying cooling loads, where the refrigerant demand is not constant. The primary purpose of a high-pressure receiver is refrigerant storage. Due to load fluctuations, the demand for refrigerant in the evaporators will vary over time. The high-pressure receiver provides the needed buffer to accommodate these fluctuations by temporarily storing excess refrigerant when the load decreases and supplying the refrigerant when the load increases. From an operation and maintenance standpoint, the high-pressure receiver is useful as it provides a location where the refrigerant can be stored while maintenance tasks are performed.
So let's talk about the difference between a through type and a surge type high-pressure receiver. I have both depicted up here on the board. The first is the through type, and it's pretty straightforward because in a through type, the ammonia or whatever refrigerant you're using flows through the vessel. You can see from the condenser entering the vessel, and then there'll be some level in the vessel, and it will pass through the vessel and go out to the system. That's our through type high-pressure receiver. In the surge type, on the other hand, the refrigerant from the condenser never actually directly enters the vessel. Instead, from the condenser, it drains and is supplied directly to the system. So there is a connection to the vessel, and refrigerant is allowed to enter the vessel based on load in the system. It surges up, or excess can be supplied out of the system. So that's a simple depiction of the difference between a through type and a surge type high-pressure receiver.
High-pressure receivers can be designed for both horizontal and vertical orientation. Vertical receivers offer the advantage of occupying less square footage, but a downside is that valves on top of the vessel can be difficult to access. It is not uncommon for larger systems to have multiple high-pressure receivers. When this is the case, the HPRs are typically interconnected so that they operate in concert with the same liquid level.
High-pressure receivers are one of the coolest vessels, and that's just simply because they're big. Okay? The high-pressure receiver is typically the largest vessel in a refrigeration system, and therefore it's pretty impressive to show someone. Now, keep in mind, they're not required to have a high-pressure receiver. There are critically charged systems that don't have a receiver. If there's a very consistent load in a system, high-pressure receiver may not be necessary. But for any medium or large system, you're gonna more than likely see some sort of high-pressure receiver. And that's because it provides a location to store refrigerant that's not being used at any given moment. And that's really helpful with fluctuating loads. It also is helpful when you need to do maintenance. You need to pump down something. Where do you put the refrigerant? A high-pressure receiver is usually that vessel. For those that are operating an ammonia refrigeration system, the high-pressure receiver is often the vessel that's modeled in the worst case release scenario in the hazard assessment and offsite consequence analysis. So it's important from that vantage point as well. And the final thing I'd like to say about high pressure receivers is that's where you're gonna find your king valve. And that's a really important valve that needs to be clearly identified for operators and emergency responders, because in the event that there is a emergency related release, it's very important that valve can be accessed, quickly found, and isolate the flow of refrigerant from the vessel.
A variation of a standard high-pressure receiver is the combination thermosiphon high-pressure receiver. In this arrangement, the vessel has an internal chamber located near the top of the vessel. Liquid from the condensers flows into the top of the vessel and collects inside the thermosiphon chamber so it can be supplied to the oil coolers. Overflow from the thermosiphon chamber collects at the bottom of the vessel, which serves as the standard HPR. Another variation is the controlled pressure receiver that operates at an intermediate pressure between the compressor discharge pressure and the suction pressure. Smaller systems may be configured with what has been termed a pilot receiver. Since pilot receivers are physically small, they generally cannot hold the system charge, and the level in the pilot receiver is maintained through the use of a float valve. Most high-pressure receivers can be configured with some or all of the following: liquid level indicator with isolation and purge valves, king valve to stop the flow of ammonia from the vessel, condenser drain isolation valve, relief valve assembly, equalizer line connecting the HPR to the high-stage discharge pipe. The liquid injection cooling isolation valve would be only necessary for systems that utilize compressors that are liquid injection cooled. The King valve is the most noteworthy valve in a refrigeration system. Typically, an HPR will be configured with a single King valve that can be closed to stop the flow of ammonia from the vessel. This valve must be clearly labeled to aid first responders during an emergency. Some King valves must be manually operated, but others utilize a solenoid valve that can be activated remotely.